I am a VR prototyping applications engineer. So we're kind of looking at the gamut of different VR prototyping that's going on in the entire space, everything from mobile to VR. And I'm here just to kind of present to you some of the interesting things that you can do with RealSense technology in the context of both high-end VR and low-end VR. So if you haven't never heard of RealSense technology, and I've talked to a lot of people in this room so far, some of you even have our cameras already, the group started at Intel in around 2011, tasked with adding senses to the brain being Intel's x86 CPU. So really, we're a group focused on sensors and sensing, no matter what type of input modality. It could be audio, speech, but more recently, we've actually been focused on depth cameras. So a lot of you know depth cameras from the Kinect 2009 release by Microsoft. They sold about 25 million units so far, and that was the sort of entry of depth cameras into the consumer space. So we looked at a couple different aspects of depth cameras and said, how are we going to innovate here? And we did it with price, performance, and really size. So here we have our two current peripherals available on Intel.com that you can order today. The long, blue one here is the Intel RealSense R200. It most closely resembles the sort of nominal range of the Kinect, working with pretty good accuracy out to about 3.5 meters. The other interesting thing about this camera is it's fully non-constructive, so it works, constructive interference, so it works well with other devices with this technology, and also outdoors. On the other side, we have the Intel F200 camera, which is really designed for embedding in sort of more laptop lids, and it's for really hand-based interactions. The one thing I want to note here is that these peripherals are absolutely huge, but we've actually reduced the size of the actual modules contained within, and we're in all kinds of new form factors today, including drones, robots, phones, tablets, what have you, and really what we want to see is this hardware embedded in VR headsets. So what are the areas that we're looking at in the context of VR? We can talk about high-end and also low-end. Specifically, we're looking at physical and digital interaction in the style of Leap Motion. It's an amazing revolution in computing. You don't almost realize that you're using a computer anymore. But also sensing and reconstructing reality, which is the classic hardest computer vision problem, which is how do you make sense of everything in your environment? And this can extend to face tracking and object recognition, 6-degree of freedom pose tracking. Really, the entire spectrum of computer vision is one of the sort of areas that we're taking on as a group. So this is actually a point cloud. This is actually what you would do on basically day one of getting one of our cameras. And by default, this information is 3D. And I want to sort of emphasize that if you're a game developer, you don't need a PhD in computer vision to use this kind of data. It's almost just drop it into your game engine and use it directly. And the sort of innovation of the RealSense group is that we accelerate this data acquisition. So if it's embedded in a mobile device, you should be able to get this data for free from a chip that our group builds. So the rest of your system is available for VR rendering. Since this data is by default 3D, we're working in a sort of area that we like to call synthetic reality, which is bringing point cloud data and real-world data from the depth camera back into a 3D space on your headset. And so this is a sort of modified mixed reality spectrum. Some researchers in literature call this augmented virtual reality, but it sort of more closely describes basically bringing more 3D content into your world inspired by your surroundings. So what can you do with this data? I'm just going to share a little anecdote. Every time I demo the Vive in our lab at Intel, the fence gets you only so far in sort of collision detection and avoidance, the virtual grid that you see when you try to violate the boundary conditions. One of our SDKs that we provide is a sort of volumetric reconstruction approach, what can be done in real time. So imagine you have a camera mounted in your headset with RealSense technology. You can sort of integrate all of the depth of your environment in real-world coordinates and drop that directly into your scene in real time. Why is this important? Well, this isn't exactly something you would render. You have a game that you're running on top of this, but you can use it as a very accurate collision mesh to detect if your controllers or hands or anything else is getting close to any one of these geometric objects. And so, although this can be done in real time, you also have the flexibility of using the point cloud directly. Since this wouldn't necessarily integrate dynamic obstacles, this is best for static. You can also use the point cloud directly for dynamic collisions and occlusions. Also, you can use the same reconstruction functionality to scan an entire avatar. This is particularly cool because you can upload this to an API like Body Labs and automatically get back a fully rigged avatar ready for puppeteering and avatteering in your game engine. So these are actually untextured models, but you can use fully textured models. So just imagine social experiences with real models of yourself in VR. I'm also happy to announce that we have a developer kit for mobile. I'm holding it right here. Some of you have seen this tonight. This is an Intel x86 phone, so not necessarily a consumer product. But as a technology enabling group, we would like to see this technology integrated into as many different form factors as possible. So you can sort of buy this, pre-order this device today on our website. And what it is it's a RealSense depth camera with the Tango API. We worked closely with Google to sort of define what it means to sort of have a both high quality depth sensing and 6 degrees of freedom pose tracking. So everybody knows exactly how important 6 degrees of freedom is, and this is really sort of where the industry is heading. A lot of people have tweeted on the subject, and there are startups funding all the time trying to solve this exact same problem. But as a group, we sort of realized that you can't just solve 6 degrees of freedom with a phone quality IMU and an RGB camera sensor. You almost always need extra hardware. And so if we as developers take on that burden to actually solve this problem with additional hardware, you as VR developers can do more interesting things. So that's the Tango API, 6 degree of freedom pose tracking. You can also use the headset in a sort of VR mode, and you can drop this into any sort of VR headset you can buy on eBay or Amazon. But the idea is that you can also use basically the depth camera to do real-time collision detection, so you'd know if you're about to run into a wall when you are running around your room. So really, we've already heard from Dave at Lead Motion about the importance of quality interactions in VR, and that's an amazing demo that they showed. And I just want to say that with the depth camera, it's a sort of different kind of information that you can use. Although we don't have an API today that does skeletal hand tracking, I want to emphasize that this is a sort of raw, unprocessed image directly from our camera sensor. And you see, this is actually me holding up my hand directly in front of a headset. And it's just really easy data to work with. So by default, it is 3D. And you can throw up basically a little convex hull around this and collide and do gestures and pointing and what have you.